In part 2 of our collection of videos on application examples of vectors, we're going to look at an example that involves displacement and travel. Now, displacement, when I think about that word displacement, roughly speaking, what that means when we talk about displacement is a net change in location. So for those of you that will take physics next semester, or for those of you that will take Calculus 1, you will talk about the difference between displacement and distance in those courses. But for now, you can just think of displacement as a net change in location. Okay, so the example that we are looking at is a car drives along a road for 3 miles in a direction 15 degrees north of east. Find the components of the displacement vector. All right, so what we're given is some instructions about the direction that a car is traveling, and those travel directions are given in terms of the cardinal directions. So we have north, south, and east and west, and this car is driving for 3 miles in a direction 15 miles north of east. So when I see that north of east, what I want to start with is I want to start by thinking about a direction which is east, and then I want to rotate in a north direction toward the north, and I want to rotate an angle of 15 degrees. So what we have here is a vector starting at the origin and shooting outwards. The length of that vector, well, our drive is 3 miles, so the length of this vector will be a length of 3, which we can think of as 3 miles. So the two pieces of information that we are given in this problem are the magnitude of the vector. So let's name our vector, maybe we'll name it u for this example. The magnitude of our vector is 3 miles, so that's the length of the vector. And the direction is 15 degrees north of east. Okay. And our job is to find the components of this vector, and this vector u is our displacement vector. So when we talk about finding the components, what we're saying is we want to find the x component and the y component. Now I'm going to draw a picture separate from our diagram up above, just so that I have a little bit more space to draw things. So we have our vector, which we're naming u, and we have an x component and a y component. And so the x component we name ux, and the y component we name uy. And we have this angle of 15 degrees. And we're told that the magnitude of our vector u is 3. So if I want to find ux and uy, then what I want to think about is I want to think about what ux and uy are with respect to our angle. So we'll start with ux. And ux is our adjacent side with respect to our angle of 15 degrees. So I want to think about the cosine function, because cosine is adjacent over hypotenuse, and we know the length of our hypotenuse is 3. So cosine of 15 degrees is equal to the adjacent side, which is ux, over our hypotenuse, which is 3. And so I can multiply both sides by 3, and we have 3 times the cosine of 15 is equal to ux. And then I can use the calculator, making sure it's in degree mode, to find that 3 times cosine of 15 is 2.9. Okay, cool. So our x component is 2.9. So we're going to need that piece of information. I'm going to box it off. All right, now for the uy value, with respect to the 15 degrees, uy is the opposite side. So we're given the hypotenuse, we're looking for the opposite side, so we want to think about the sine function. And sine of 15 is opposite, which is uy, over hypotenuse, which is 3. And now I can solve this equation for uy, so I'll multiply both sides by 3. And I get that uy is equal to 3 times the sine of 15 degrees. You should double check when you type this into your calculator that you get 0.78. At least that's what I got, and hopefully you'll get the same thing. Okay, so we've found our two components, and now I'm going to go back to our vector that we were looking at. So we can write our vector u as our x component is 2.9, comma, our y component is 0.78. And so we have found the components of our displacement vector. Okay. Now, in terms of interpreting what that means, another way to think about that is if I go back up to our diagram up above where we had our cardinal directions, and we had our person driving their car, and let's see, I want a different color, and the person driving the car drove 3 miles at an angle of 15 degrees north of east, and they ended up at this particular location, which I better make that a little darker, at this particular location right up above. And what these components tell us is that rather than driving 3 miles at 15 degrees north of east, this person could have driven 2.9 miles east and then 0.78 miles north. And so driving 2.9 miles east and then 0.78 miles north will get you to the same place. To the same location. Okay, so again, we can take our vector, we can break it up into its components, and those components tell us direct cardinal directions, in this case 2.9 miles east and then 0.78 miles north, and that will get us exactly to the same place and will give us the same displacement.